1 gram of antimatter contains more explosive energy than the bomb dropped on Hiroshima. And here's the crazy part. Antimatter is real, and scientists are making it right now in underground laboratories across the world. If antimatter ever touched your hand, you wouldn't just get burned. Both your hand and the antimatter would instantly convert into pure energy in a flash brighter than the sun. So what exactly is antimatter? Why does it explode when it touches regular matter? And why is the universe made of matter instead of antimatter? By the end of this video, you'll understand one of the most mind-bending concepts in physics and why antimatter might be the key to traveling to other star systems. Let's start with the basics. To understand antimatter, we first need to talk about what normal matter actually is. Everything around you, your phone, your body, the air you breathe, is made of atoms. And atoms are made of 3 basic particles: protons, neutrons, and electrons. Protons have a positive charge. Electrons have a negative charge. Together, they balance out to create stable atoms that make up everything in our universe. Now here's where it gets weird. In 1928, a physicist named Paul Dirac was doing some complex math about electrons when his equations predicted something impossible. His math said there should be a mirror version of every particle. An electron with a positive charge instead of negative. A proton with a negative charge instead of positive. Scientists thought this was just mathematical nonsense. Until 1932, when physicist Carl Anderson discovered the first antimatter particle in cosmic rays hitting Earth from space. He found a positron, an anti-electron with a positive charge. Dirac's math was right. Antimatter was real. Since then, we've discovered that every particle has an antimatter twin. Antiprotons, antineutrons, antiquarks. You could theoretically build anti-atoms, anti-molecules, even anti-people. An antimatter version of you would look identical, think identical, and live an identical life. Except for one crucial difference. If you ever touched your antimatter twin, you would both instantly cease to exist. This is called annihilation, and it's the most powerful reaction in the entire universe. When matter and antimatter meet, they don't just explode. They completely convert into pure energy according to Einstein's famous equation, E equals mc squared. This is 100% efficient energy conversion. Nuclear bombs? Only about 0.7% efficient. Antimatter annihilation is 140 times more powerful. Just 1 gram of antimatter meeting 1 gram of matter would release the same energy as 43,000 tons of TNT. That's 3 times the Hiroshima bomb. 10 grams could power New York City for an entire day. A few hundred grams could send a spacecraft to Mars in weeks instead of months. So here's the obvious question. If antimatter is so powerful and so real, where is it? Why isn't the universe full of antimatter? This is one of the biggest unsolved mysteries in physics. And it all comes down to what happened in the first second after the Big Bang. According to everything we know about physics, the Big Bang should have created equal amounts of matter and antimatter. 50% particles, 50% antiparticles. And if that had happened, all the matter and antimatter would have immediately annihilated each other. The entire universe would have converted into pure light and energy. There would be no stars, no planets, no you, nothing but an empty universe filled with photons. But obviously that didn't happen. Something broke the symmetry. For every billion antimatter particles created, there were 1,000,000,001 matter particles. That tiny imbalance, just one extra particle per billion, meant that after all the annihilation was done, a small amount of matter survived. That leftover matter became everything in our universe. Every galaxy, every star, every atom in your body exists because of that 1 in a billion imbalance. But why was there an imbalance? Why did matter win? As of 2026, we still don't have a complete answer. This is called the baryon asymmetry problem. Some physicists think antimatter might behave slightly differently than matter in ways we haven't detected yet. Others think there might be entire galaxies made of antimatter somewhere out there. Meanwhile, scientists in 2026 are creating antimatter in laboratories to study its properties. And it's insanely difficult and expensive. At CERN in Switzerland, The Large Hadron Collider smashes protons together at 99.99% the speed of light. These collisions create antimatter particles. But there's a problem. The antimatter particles only exist for a fraction of a second before they hit regular matter and annihilate. Storing antimatter is incredibly hard. You can't put antimatter in a regular container. It would touch the walls and explode. So scientists use magnetic fields to trap individual antiparticles in a perfect vacuum. In 2025, CERN scientists successfully stored antimatter for over 1,000 seconds, the longest ever recorded. But we're still talking about just a few antiprotons. And antimatter is phenomenally expensive to make. Current estimates in 2026 put the cost at around $62 trillion per gram. That makes it by far the most expensive substance in existence. A single gram costs more than the entire gross domestic product of many countries. So if it's that expensive and hard to make, why bother? Because the potential applications are absolutely revolutionary. First, antimatter propulsion. A spacecraft powered by matter-antimatter annihilation could reach a significant fraction of light speed, making interstellar travel actually possible within a human lifetime. NASA has studied antimatter propulsion concepts. With just 10 milligrams of antimatter, you could send a probe to Alpha Centauri in 40 years instead of 40,000 years. Second, medical imaging. Positron emission tomography scans, PET scans, already use antimatter to detect cancer and brain disorders. You've probably had antimatter injected into your body if you had one. And third, fundamental physics research. By studying the tiny differences between matter and antimatter, we might finally solve the mystery of why we exist at all. Experiments at CERN in 2026 are measuring antimatter properties with unprecedented precision, looking for any asymmetry that could explain why our universe exists. So antimatter isn't just science fiction. It's real, it's powerful, and it might be the key to both our past and our future in the cosmos. Think about it. Every particle in your body survived a cosmic lottery that had 1,000,000,000 to 1 odds against you. You're literally made from the universe's leftovers after the biggest explosion ever. If this video blew your mind, smash that like button and subscribe to Your Space Wizard for more mind-bending space science that makes the universe feel magical. The universe is stranger and more wonderful than we ever imagined. And antimatter proves that sometimes reality is more mind-blowing than any science fiction.